Hi, my name is Rishishan Shanmuga and my metric number is 2400485. In this slide, I created a normal probability plot using the Excel to access whether the age data of the respondents follows a normal distribution. As we can see, the data points mostly align along the straight line. This suggests that the age data is approximately normal distributed. However, there are some slight deviation at the upper end of the plot. This might indicate mild skewness or possible outliers in the data. Overall, the plot shows that the age data is mostly normal with only a slight deviation. Now we move on to the next analysis. I conducted a two-sample t-test assuming unequal variances to access if there is a significant difference in the mean ages between male and female respondents. The mean for male and female ages are shown as 25.57 and 27.59 years respectively. The test purpose is to compare whether these means are statistically different from each other. As per the results shown in the table, you can see that the t-statistic is negative 1.2384 and the critic t-value for a two-tailed test is 2.0154. Moving on to the conclusion of the t-test analysis, the p-value for the two-tailed test is 0.2221, which is greater than the significance level of 0.05. Since the p-value is higher than 0.05, we fail to reject the null hypothesis. This means there is no statistically significant difference in the mean ages of male and female respondents. Next, let's look at the probability of the sample mean age is greater than 26 years. Using the Z-score formula, I calculated the Z-score as negative 1.2059. Based on this Z-score, the probability that the sample mean is greater than 26 is 0.4184 or 41.84%. This means there is 41.84% chance that the sample taken from the population will have the mean age greater than 26 years. Finally, I calculated the probability that the sample means fall between the ages of 23 and 25. Using the Z-score formula, I calculated the Z-score for 23 and 25 years as negative 5.8894 and negative 2.8692 respectively. The probability of the sample mean falling between 23 and 25 years is 0.0021 or 0.21%. This means that there is very low probability, which is only 0.21%, that the sample mean will fall between the 23 and 25 years.
Hello, I'm Dineshwaran. For question 2a, we are required to construct a 90% confidence interval for the difference in proportion of passengers who are satisfied with two facility quality items, FQ1, sufficient seat capacity, and FQ2, disability friendly features. The proportion of satisfaction are for FQ1 49.09%, for FQ2 63.64%. We calculated the standard error SE as 0.661 and the margin of error ME as 0.1087. Using this, the confidence interval was found to be between negative 0.2542 lower bound and negative 0.0368 upper bound. Since 0 is not included in this interval, we can conclude that there is statistically significant difference in user satisfaction between the two facility quality items for the LRT service.
Hello everyone, my name is Li Boyu. My matrix number is 24058-035. I'm going to explain question 2b. I report on the statistical analysis process and conclusions regarding the difference in satisfaction between female passengers and male passengers based on dataset 6. In terms of samples, the sample size of female passengers is 80 and for male passengers is 30. Through preliminary calculations, we obtained that the variance of satisfaction for female passengers is 0.906 and for male passengers is 0.778. In terms of means, the mean for female is 3.2938 and for males is 3.5333. Step 1. I define the research hypothesis. The null hypothesis is the average satisfaction of female passengers is less than or equal to the average satisfaction of male passengers. And the alternative hypothesis is the average satisfaction of female passengers is greater than that of male passengers. Step 2. I calculate the t-statistic. The calculated t-value is approximately negative 1.2134. Step 3. I calculate the degrees of freedom. The degrees of freedom is approximately 55.31. At the 5% significance level, the critical value is approximately negative 1.673. Comparing the calculated value with the critical value, I found that the calculated value is greater than the critical value. Based on the above result, we fail to reject the null hypothesis. This means that under the one-tail test at the 5% significance level, the existing data does not provide sufficient evidence to support the conclusion that the satisfaction of female passengers is higher than that of male passengers. That's all. Thank you.
Hello everyone, my name is Liu Qiuyan. I'm responsible for question 3. First is hypothesis testing with related samples. I used a paired sample t-test to compare the difference in the scores of FQ1 and FQ3 in the questionnaire. Both questions were answered by the same group of respondents, so the data were paired. The results show that the mean difference is 0.136 and the t-value is 1.405, which is lower than the critical value plus and minor 1.982. So the null hypothesis cannot be rejected. It indicates that the scores of FQ1 and FQ3 are consistent, reflecting the stable attitude of the respondents and the good reliability of the questionnaire. Second is analysis of variance. Analyze of the effort of different levels of education on PS2 item ratings. The average scores of the three groups are close, and the F value is 1.084, which is less than the critical value of 3.08. The results show no significant effort of education level on ratings, indicating that this variable had a small effort in this. No significant difference were found in other tests. Respondents were consistent in their attitudes towards the questions, and education had little effort on ratings. It is suggested that future research can introduce variables such as age and gender and combine interviews with other methods to more comprehensively understand and views of respondents.
Hi, my name is Arvin, son of Nanta. My matrix number is 2400417. On this slide, I'll be explaining the chi-square test of independence, which helps us understand whether there is a significant relationship between employment status and private transport. In our analysis, we are trying to determine if a person's employment status influences their likelihood of using private transport. The goal is to see if these two factors are connected in any way. On this slide, we have the data that shows how many people in each employment category use or do not use private transport. The null hypothesis assumes that there is no significant relationship between employment status and private transport. On the other hand, the alternative hypothesis suggests that there is a significant relationship between the two. Looking at the data, we see that, for example, 29 students use private transport while 25 do not. This data help us move forward with the calculation needed to test this hypothesis. On this slide, it's into the calculation. Using the observed data from the table, we calculate the expected frequencies. This represents the values we would expect to see if there were no relationship between employment status and private transport. After this, we calculate the chi-square statistic, which gives us a value of 7.9270. Comparing this with the critical value of 7.815 for 3 degrees of freedom at significance level of 0.05, we see that our statistic exceeds the critical value, indicating that the difference between the observed data and expected value is significant. The p-value comes out to 0.0475, which is less than 0.05, confirming the statistical significance of the result. As a result, we reject the null hypothesis. This means that there is a significant relationship between employment status and private transport. In simple terms, employment status does influence whether someone is likely to use private transport.
Hello everyone, my name is Shenjia and I'm responsible for part B of question 4, the man-U-weighted test. The man-U-weighted test is a non-parametric test used to compare whether the median or distribution is the same between two sets of independent symbols. And here is the steps. First, data preparation. Second, measure sort. Third and fourth, calculate rank summary and the U-value. The last one, hypothesis testing. In this question, I choose device 4 and gender as the research date. From date 6, there are 30 males and 18 females, totally 110 people. Then we use R formula, we can get R1 and R2, just the rank summary. Then we use the U formula, we can get U1 and U2. And in these questions, we choose smaller U, just the U2. Then we could use the U-value to get the final date. The p-value is 0.5754. And now we could use the new hypothesis we call H0. The distribution of satisfaction is the same for both groups in both sexes. And we use the p-value, which is bigger than 0.05, and H0 could not be rejected. That is, there was no significant differences in satisfaction for device 4 between the male and female groups. That's all. Thanks for listening.
Hello, I'm Dineshwaran. For question 4C, we use the Kruskal-Wallis test to assess whether there are significant difference in median age across 3 education levels: high school, bachelor's degree, and graduate or above. The null hypothesis stated that the median age does not differ significantly across these groups. To test this, we calculated the rank sums for each group. R1, high school 742, R2, bachelor's degree 3850, R3, graduate or above 1513. Next, we calculated the test statistic H, which turned out to be 45.6177. For the critical value, using a significance level of 0.05 alpha and degrees of freedom of 2, we found the critical x-square value to be 5.991. Since our h value is greater than the critical value of 5.991, we reject the null hypothesis. This indicates that there is a significant difference in the median age across the education groups.